Hello, and welcome to the fourth section of this course, Evaluate Algorithms. In this section, you will learn to use several classification techniques in order to evaluate your machine learning algorithms in R. In the first video of this section, we will understand the concept of classifying using the support vector machine approach. The SVM uses the kernel trick to build a highly accurate and efficient model. It is a powerful technique that maps nonlinear data to higher dimension space. This is done so that our data can be easily separated with a linear boundary or hyperplanes that generally maximize the margin width among different classes. This in turn solves the issue of overfitting by making use of regularization and also eliminates the problems of local optima or multi-collinearity. For the purpose of this video, we will use the E1071 package to help us easily apply and work with the SVM classification technique. We will then predict a class based on other variables using the built model. In order to classify using SVM, we will first load the E1071 and caret package. Next, we will read the data. We will now convert the outcome variable class to a factor. Now let's go ahead and partition the data. Finally, we are ready to create our SVM function. But before that, we will understand how our model works. The SVM function will determine whether the model is of classification or regression type depending on the nature of the outcome variable. If the outcome variable is a factor, SVM will go ahead and build a classification model. For this, our arguments will be the model formula and the dataset. We can also pass the outcome variable and predictor variables separately as the x and y arguments. Okay, now that the explanation is out of the way, we will proceed to build our model. The resulting SVM object is mod, and it contains the model to create an error or classification confusion matrix. We will check the performance of our model on training data by generating a simple error or classification confusion matrix. We can see that the SVM model retains the fitted values on the training partition. Hence, we can eliminate the step of creating predictions. We can access these fitted values through fitted mod. We will now check our model's performance on the validation partition. We will generate the model's predictions for the validation partition using the predict function. The arguments for the same will be the model and the data for which we need predictions. These predictions will help us generate the associated error classification confusion matrix. Finally, we will use the plot function to plot the model's results. Like before, the arguments are the model and the data for which we need the plot. The output plot is as shown on screen. Even though our data has more than 2 predictors, we can show only 2 in this plot. Hence, we have selected skew and variance to be shown. We can control the scaling and type of our model by changing the arguments in our SVM function. By default, for the sake of building a good model, SVM scales all the predictor and outcome variables to 0 mean and unit variance before building a model. We can use the scale argument to control this. If the length of the vector is 1, then it can be used as many times as needed. In terms of the model type, by default, when the outcome variable is a factor, SVM performs classification. When the outcome is numeric, it performs regression. We can alter this by using different values for type. That's all for this video, where we learned how to evaluate our model by applying the support vector machine classification technique.